I would like to talk about heat capacity and its relationship to energy. So I'm making myself some tea and I want to heat it up to 60 degrees Celsius. Now this process will require some energy. After all, I do need to turn on the stove and then some energy will be transferred from the stove into the water. Now let's say a friend comes along and I still want my tea to be at 60 degrees, but now I need more water. So now I have more stuff in my kettle. Another word for stuff is mass. So I have more mass. I would expect the energy requirement to go up. After all, I'm heating up more things. And you probably know that intuitively as well. More things means you need more energy to heat it up. And now let's say my friend says, well, 60 degrees is not exactly hot. We should really boil the water. So we're going to heat it up to 100 degrees Celsius. So that too will require an increase in energy. And once again, you might know that intuitively, higher temperature means more energy is required. So here's another fatter green arrow indicating that we need more energy. So the energy requirement depends on mass, but it also depends on the change in temperature, or delta T. There's one final thing missing here. Not all things heat up the same way. So say this water will not heat up the same way as this sandwich, and you know that intuitively as well. The thing that accounts for the differences in substances or their ability to heat up is the specific heat capacity, which is often given the symbol Cs. So here we can see that the energy will depend on three things. It will depend on the mass, so more stuff means more energy. It will depend on the change in temperature. The bigger the change in temperature, the bigger the energy requirement. And it will depend on the specific heat capacity, or on how well a substance will take up energy. Now finally, you might wonder, what is the unit for Cs? Well, we can work that out. On the left-hand side, we have energy, which is in joules. Mass, we're going to make that grams. Temperature, we'll make that Kelvin. So the question is, what is Cs? Well, we have to have joules at the end, so joules have to be on the right-hand side as well. However, grams and Kelvin need to be cancelled, which means we need to divide by a gram, and we need to divide by Kelvin. Because now, if we multiply, we can see that this gram and this gram will cancel, and this Kelvin and this Kelvin will cancel, and you will be left with joules alone.